castle where the digital dreams come alive. CESCG takes place from May 1 to 5, from visualization to the virtual space. Scientific sessions take their place.
Hello everyone. So I'm Marina Lima Medeiros. I am a PhD student at TU Wien, but I also work at VRVIS in Vienna. And I'm here to present how the state of my PhD research proposal actually is. So first, I don't know if any of you ever used Google Earth VR. For me, it's very interesting that you can have a relationship with the Earth model in 3 different ways. So you can hold it in your hands, it's attached to your controllers, and you can point at it. Also, you can see it in a bigger way, that you can have a relationship with it and walk around it, and then you can immerse yourself into it to the point that you can see cities in real scale. What's interesting is that mixed realities, it can subvert our space-time logic, and we have seen this not only in Google Earth VR, but in many other projects and applications. So one is, for example, we have this project that has been presented here many times, I think, is the nanotilos, and then you can actually navigate through a virus. So something that we cannot even see with our bare eyes, you can just navigate and travel through it to understand the protein relationships inside of it. Also, you can do this with even abstract data. So we have also this project called the VR Netzler, that you can just look into relationships between genes and in this network of relationships. So you can navigate or see through outside. And this is also, you can change the proportion between the body of the user and digital objects, for example. This is a master's student from Bianca Severin, also from TU Vienna. She's an architect student, actually, and she created this application to visualize urban data in virtual reality. And you can, in this application, scale up and down the model up to the point that you can go to a one-to-one scale. So you can actually visualize this model in many different ways. And when I say space-time logic, it's because you can also see different time relationships. For example, this is my master's thesis from some time ago, when I visualized the model of a building that was demolished decades ago in Rio de Janeiro. I'm not going to focus on these time relationships in my PhD, but I think it's worth it to mention that there's not only the space relationships that are changed or can be subverted in mixed reality, but also the time. And why this is interesting for domain experts, for example, you can expand the interactive work environment beyond the desktop screens, and this can lead maybe to new insights or better solutions for old questions, and you can even maybe find more productive workflows. And the issue is that the best practices and standards for this kind of interactivity into space do not really exist yet. And when it actually adds value to a work routine is also an open question. So we can actually now can create different applications for domain experts, but one of the main question, or from my work, for example, that I get is like, does this really adds value to the process, or does this really makes their work routines better? And one of the issues that we humans, we don't perceive space equally. So it has been well established already in the literature since the end of the 90s that we have, for example, we have the personal space, which is 1.5 to 2 meters diameter circle around us. There's the space where we can touch things, we can grab, we can manipulate things. That's where we usually work. And also we have the action space that goes from 1 to 30 meters away from us. And this is where we have most of our social interactions. So whereas up to where you can still see the face of a person and you can recognize someone. And then we have the vista space that is more than 30 meters away from you to the infinity and beyond, where you don't see details anymore, and this is mostly a background for your interactions. And if we think, for example, back to the work of Bianca, what she was doing was that she was taking this 3D model of the city and putting it from the personal space where she manipulates it to the action space where she can walk around up to the vista space when she doesn't see a lot of details anymore. But maybe into changing into those different spaces, that's where the importance and this added value comes from. So there is some related work already done in this sense. I mean, the classification of interaction patterns and techniques has been done. There are several also surveys about it, but not specifically done for this kind of change of perceptual spaces. And also there are many works in design spaces for people who work in VR or AR, but they are most also connected to data analysis and small objects on how to place those objects around the user. One specific work that I found that can be very related is this work from Wagner and al. That they analyze different setups, so home scale, isocentric or egocentric, and also large scale. So when the user could see this data set from outside, could manipulate it, or go inside until the point that this data set became basically the environment that is immersed into it. In the conclusion, they mentioned that this go in between scales, spaces, improve the understanding, but there is also like further work to be done in this sense. So I have like two research questions so far. It's like working different perceptual spaces demands different 3D user interfaces and interaction techniques, or does transitioning objects between those perceptual spaces improve the usefulness of this mixed reality application? And their objectives is to analyze and classify those 3D users interfaces and interaction patterns that transition from one perceptual space to other, and their importance for work applications in mixed reality. Also provide design guidelines for the design and implementation of 3D user interfaces and interaction patterns in mixed reality according to the perceptual scale of the work activity. So the methods is to actually use those perceptual spaces as analysis categories, so try to understand when the user is moving from one to the other, or transitioning this 3D object from one perceptual space to the other. Analyze and categorize this information. I'm going to, now the plan is to work with 3 user cases. So it's 3 projects that I've been working on, and each project mostly focused originally in one perceptual space. And I'm planning to use foundational research, which is mostly a qualitative assessment to define the needs of the users. And it's a methodology that is brought from the human-computer interaction field. So the 3 use cases, so the first one is called MilGeoVA. It's a virtual reality application for mission planning. This project is already finished. Here you can see the examples of some of the navigation techniques that we used for it. So you can fly around, you can teleport, and you can also use visualize the 3D model of an area as a tabletop model where you can place the position that you're going to be, and then you can immerse into a real scale visualization. This project was done together with the Austrian Army, and all of those navigation techniques, they were actually asked by them. So we started step by step, and they were actually asking for us to include more. So at first there was only teleport, and then they asked like to fly around, and then this tabletop visualization mode also came into the process. The second use case is called DIGIHydro. So it's a virtual reality application with simulated and sensor measured data for hydroelectric power plants. So actually mechanical engineers, they want to predict maintenance of those hydroelectric power plants, and they are trying to combine and visualize this sensor data with the simulated data to come to this conclusion. And the idea of using virtual reality was to give them this situated understanding of where the sensor is placed, how the fluid behaves in this position, and what is the result of the sensors. This project is ongoing, and yeah, we are planning an evaluation of it. The third use case is called ClimaSens. It's a project on urban microclimate modeling with interactive, collaborative, and immersive planning workflows. This project is just in the start. It's still in the planning phase. We are collecting data, but it's also like an interesting project because we are very free to work as we wish with this data. And it's supposed to have some augmented reality interaction, but everything is quite open, so I'm up to suggestions of how to do. The results so far and the contributions up to date, so I've had an ISMA workshop paper in 2019, and actually that's when this idea of analyzing those interactions and this change of perceptual spaces actually came, because I did an analysis of that first project, the first use case project, and then you can see that actually the navigation interactions and the change of viewpoints, like it's most of the interactions that were implemented came from this kind of change in the proportion between the user and the 3D model. Then we have IEEE VR paper in 2022, and this paper presents this foundation research on this use case one, so we tell the process of how we got to all those solutions and how those interactions came to be in the project, and also some qualitative feedback from the domain experts. And then last year I have the poster in the Spatial User Interfaces Symposium from the use case 2. But it's just presenting the project and some of the solutions that we came up, so it's really the first phase of analyzing this project. Some open questions that I have and future work, so the second use case evaluation and a paper for it is still like an open topic. I'm looking for how to evaluate this project, and like in TUVIN, we need at least 3 papers to start writing our thesis. And this would be the second paper for the thesis. The third use case is still in planning phase. We are collecting data. All the research questions remain partially open because I just analyzed one use case so far. And also, I might have to have a re-evaluation of it or some sort of other kind of evaluation from it. So far, the methodology is pure qualitative. I don't know if it's necessary or if we'll end up having to have some sort of quantitative analysis. And this Monday, I'm going to be presenting the same project, the same research proposal in the CHI doctoral consortium, which is the Human-Computer Interaction Conference. So I also have to present this again some days. And then I have to have a proficiency evaluation when I should present this research proposal in the university to get feedback from them too. Thank you very much, and I will really appreciate your feedback.
Thank you very much for that presentation, right on time, perfect.
Yes, it was 15 minutes.
Are there any questions or comments in the audience? No immediate question yet. Then I will start. Because I found it quite interesting. So the interactions that you have shown are mostly, I would say, you are just immersed in this virtual environment, and you can see things, you can inspect things. But I think there are things that you can do in virtual environments that you cannot do in the real environment. And probably you have more advanced interaction techniques. And do you think you could use that to also, for example, do visual analysis of some sort, or do really things that are not just looking at the data, at the visualization, but really trying to extract information that you could not extract in another way?
Yeah, there is a whole field called immersive analytics that actually works with this kind of interactions and try to find out when visualizing data in immersive environments is actually more profitable, because I think from the data visualization point of view, or from the traditional 2D screen-based data visualization, is well established in the community that three-dimensional representation of data is not very good, or rarely brings you some sort of new insights, let's say. But in the immersive analytics, like some things, I think especially from trajectory and those graphs representation that you have to be, that is so crowded that being immersed actually brings you some sort of better understanding of the data. So there is something in this regard. But yeah, I didn't want to call my project immersive analytics because I work also a lot with like urban models and 3D models, and those are like spatial data. It's not abstract data. So I wanted to find a way of discussing this that I don't have to separate. It's abstract data or it's like spatial data. Like, is that a way of? But that's how I'm trying to figure out so far.
Mm-hmm. Okay, thank you. Any question? Otherwise, I have a follow-up question to that.
Yes.
Because obviously this was also what I thought about, immersive visualization in general, because you can show things in a spatial domain, in a virtual spatial domain that have no spatial domain. So if you apply some mapping, and you can visualize abstract data, for example, in 3 dimensions or also over time. And I think evolutionary, our brains are hardwired to recognize places in 3 dimensions and over time. And so probably there is a benefit in exploiting these mechanisms in the brain to maybe find features in abstract data as well, if you transform them into the in the spatial domain.
Yeah, I agree. So I think that there's a lot of potential that haven't been explored yet.
And I would have one more remark, or maybe also question. In your first research question, so you stated that for different spaces you might need different interaction techniques. Or
yes.
Yeah, something along these lines. And I thought that even within the same space, you might need different interaction techniques based on the task that you have.
Yes.
Because sometimes you want to interact with what's right in front of you. Sometimes you want to, I don't know, grow that space, or to see what's outside, or I don't know. So I think it's not just related to the space itself, but also to your task that you have.
Yeah, I agree, and sometimes they even might be redundant somehow. For example, we had in the first use case, we have like teleport, and we have the flying mode, and and then you do both of them in this when you are in this real scale scenario, like immersed in the 1-to-1 scale 3D model. And basically, there are some points that you can go there with teleport, or you can go with the flying mode. The flying mode that will then give you that you can just like fly above and see things really from a more distant point of view. But then if you fly so much, then maybe go into the tabletop mode is more profitable because you can just walk around. And I think what might be interesting is that, they might be complementary in just one or the other. But also, another thing is, like, for example, this second use case, we are working together with those engineers, those mechanical engineers, fluid engineers, and they see a lot this 3D model of the water turbine in desktops already, and they already compare a lot this data in the desktop. So at no moment they asked, and I asked them if they really wanted to have like a miniature model of this water turbine that they could do the pointing, and then I will go to this place or not. No, they don't care. But it's also like this is really inside this action space. So but since we have like also a Y axis that you can move around, so you have to fly around. Like just walking would not allow you to go through the whole thing. But they never asked like a simplified model or to scale up and down. I asked more than once, do you want to scale up and down the model? They said no, we don't care, because they have this zoom in, zoom out in the desktop application. But they never go inside a water turbine.
I mean, it is also my experience that engineers are very fond of what they already know, the tools they have.
That's true.
Maybe that's also a hurdle for them.
Yeah. I mean, if they only had this VR application, maybe this zoom in, zoom out, or scaling up or down would be interesting for them. But since they already work with the VR as a complement to all of this, then they don't care. We just want to fly around, and then we only have fly around in the second use case.
Okay. Yeah. So I think we would have time for one more question.
Hi, thank you for your nice presentation.
Thank you.
My question is, what is your idea on like quantitative validation of, for example, first use case, using like different navigation techniques, for example? Will it be like the time spent on planning the mission, or what is your idea on this?
Yeah, so recently I found a paper that has like this triangular analysis that they checked the most. They were doing this for multiple interfaces, but they were checking like how long the people would use different interfaces to work in the same project. So they had like someone in AR, VR, like I think AR with a tablet, someone with a VR headset, someone in the desktop, and they were checking those times. So I thought I would go, or actually check how many times the person goes from one space to the other. So how many times you need to go into the small scale to the big scale. And yeah, that's my idea. But I still have no idea if we're gonna do this or if it's necessary or how to do this. Yes.
Thank you.
Okay, great. So if there are no further questions or comments, then let's thank Marina once more.
Thank you. Thank you.
Send to the beach where the pixels play, from rendering to VR. It's a pixel away.